All right, our last video of the lesson, we're going to work on testing a conjecture. For the conjecture, test the conjecture with several more examples or find a counterexample to disprove the conjecture. So if we can disprove it with a counterexample, let's do that. If we can't think of a counterexample, we just want to test it several times to show that it is proving true for the examples we're coming up with. So our first conjecture is a polygon with 4 congruent sides is a square. So let's draw a polygon with 4 congruent sides. And you know what? Sure does look like I drew a square, doesn't it? So I am showing an example that supports the conjecture. I did not prove it wrong. Can I think of any other polygon that has 4 congruent sides but is not a square? So what makes a square specific? 4 congruent sides, and did you see what I drew in blue? Those are right angles. A square has right angles. So can we think of a polygon that has 4 congruent sides but does not have right angles? And that's where, I'm not sure how familiar you are with all of your polygons yet, but let me share with you, we do have another polygon that has 4 congruent sides, but does not have right angles. This is called a rhombus. So we found an example that supported the conjecture, but as soon as we come up with an example that is a counterexample, it proves it false, it disproves it, this conjecture is not true. This conjecture is false because we found a counterexample. All right, let's take a look at another example. If a number is a multiple of 9, then the sum of its digits is a multiple of 9. Well, I don't know. Let's test that out. If a number is a multiple of 9, so let's look at some multiples of 9. We could do 9 times 1, 9 times 2, 9 times 3. Let's just take a look at some examples, see what we get. 9 times 1 is 9. They're saying the sum of its digits. Well, the only digit is 9, so the sum of that digit is equal to 9. So that one worked out. 9 times 2 is 18. And they're saying the sum of the digits, so 1 plus 8 equals 9. That is a multiple of 9. All right, let's see. 9 times 3 is 27. The sum of the digits, 2 plus 7, is this a multiple of 9? Yep, equals 9. All right, let's try some bigger numbers. Let's try 9 times 11. 9 times 11 is 99. Let's add those digits together to see if the sum is a multiple of 9. Is 18 a multiple of 9? It is. All right, well, let's try something even bigger. We have 9 times 125, just picked a random number. That's 1,125. Let's add those digits together. 1 plus 1 plus 2 plus 5. 1 plus 1 is 2, plus 2 is 4, plus 5 is 9. Is 9 a multiple of 9? It is. So we just came up with 5 examples that supported the conjecture. We have not come up with a counterexample. So we could sit here and try, multiples of 9 for the rest of our lives to see if this worked or not. But we came up with 5 examples that support the conjecture. So what we'll say is that the conjecture is true for the 5 cases tested. Yeah, we're showing it's true for these 5 cases. We can't necessarily say it's true for every single multiple of 9, but we can say that the conjecture is true for the 5 cases tested. All right, I just typed it out because it's a little easier to read than my handwriting on this iPad. All right, so the conjecture is true for the 5 cases tested. That's what we can conclude from that. And we just tested 2 conjectures. We found a counterexample in one, and the other one we found 5 cases that support it.